So first of all, good afternoon, everyone. Yesterday we did learn or applied the concept of reference and rotation angles to reflecting terminal arms, but that wasn't really that difficult and there wasn't much to it. What I want to focus our attention on right now are these two triangles that you need to, well, look, you don't need these triangles. You don't need to know these triangles. What you need to know are things like the sine of 30 degrees is 1 over 2, and the sine of 60 degrees is root 3 over 2, and the tangent of 60 degrees is root 3. Those are the kinds of things that you need to know. So by constructing these triangles, that allows you to use the traditional definitions of sine being opposite over hypotenuse, cosine being adjacent over hypotenuse, and tangent being opposite over adjacent to determine those trigonometric ratios. So one way or another, you need to know the exact values of those trig ratios. I've also included 0 and 90 degrees here, but if you ever want to find out the trigonometric value of, say, sine or cosine of 0 or of 90, you just use your calculator. And you will always get either the number 0 or the number 1 for sine and cosine. I don't really want to get into tangent. There's something else going on there with tangent at 90 degrees that I think we might be kind of entering a muddy topic if we get into that right now. So I want to avoid that. Somebody had emailed me last night asking me how to do a particular question, and I did the question and I realized that the answer that I have is incorrect. This is question 3B. I made a post to our Google Classroom. The answer to 3B, I don't even know why those answers were there, because the two answers that are actually in your handout are not even equal to each other. The correct answer is that x is equal to either 6 root 6, or I'm guessing it would be 12 root 3 over root 2, or 24 root 3. 12 root 3 over root 2. And thank you. And these two numbers, just want to check this out, root 2, root 6, 2. Okay. These two numbers are the same. If you were to use your calculator and calculate each of them, you would get the same number, the same result in decimal form. Later on in the course, we are going to be learning how to do what's called radical arithmetic. That doesn't mean wild arithmetic. It means arithmetic with radicals, where we will learn that these two things are equal for a particular reason. Anyway, these problems are solved by basically solving them the way you would in grade 10, except when it comes to doing the evaluation, you're not putting the numbers into your calculator, you're using those triangles to come up with exact values for the trig ratios. Does anybody have any questions you would like me to go over here? Go ahead, Ashira. Number 4? Okay. So we're asked to find the area of this triangle. And you should know that area of a triangle is 1/2 the base times the height. Different teachers in different courses have different formulas and methods of teaching this. Some say 1/2 the altitude times the height, times the base, rather. Some say base times height divided by 2. This is my go-to way to look at it. 1/2 times the base times the height. So you're given the height here. The height is 16. We just don't know the base. But you're kind of given a bit of a hint here. Well, not really a big hint, but the base is the bottom of that triangle. What we can do is focus our attention here, Ashira, on, let's take the triangle on the left, and we can use that triangle to find out the length of this side. And then what we can do is we can use the triangle on the right and use the triangle on the right to determine the length of this side. And then we can add that pink or magenta to the green and get the base of the whole triangle. So that's our job here. And, you know, to be fair, I don't know, I'll just ask you, how many of you see that this is 16? I don't think you really need to use the trigonometric ratio to know that, because the triangle itself is an isosceles triangle. In fact, if you're going to construct the triangle that you use to find the tangent of 45, you're going to have to know those two sides are equal anyway. So I don't think we need to use trigonometry there. That's 16. Let's call this distance L, and I'm going to work in this triangle and looking at where L is compared to the 30 degrees. L is adjacent to the 30 degrees, and 16 is opposite, so that means I'm going to use the tangent ratio. Tangent of an angle in a triangle is opposite over adjacent, so I can put in the 30 degrees. The opposite side is 16, and we want to find the adjacent side, which is L. So I'm going to cross multiply here first and write L times tangent of 30 is equal to 16, which means that L is equal to 16 divided by tangent of 30 degrees. And we need to know what tangent of 30 degrees is. So I'm not going to construct the triangle again. It's right here on the right-hand side. We know that if the hypotenuse of this is 2, the short side is 1, because if I reflect that triangle down, I will get an equilateral triangle, which means that that short side of the original triangle must be half of the hypotenuse, because this entire length here, if it's equilateral, must be 2. Once I know that is 2, I can use the Pythagorean theorem to determine that this is root 3. But I don't know, by a show of hands, and not everybody's here today, but by a show of hands, how many of you just know that triangle? Like if you draw the triangle, you can put the labels on it. A few people, okay? Otherwise, you have to either not use the triangle, which is a possibility, or be able to construct it each time if you don't know it by heart. So when we look at this, tangent of 30 degrees, which is what we're after in the problem, is 1 divided by root 3 because it's opposite over adjacent. So going back to the problem now, we said that that green length is equal to 16 divided by tan 30, and that means it's 16 divided by 1 over root 3. And again, I talked about this yesterday. It's okay when you divide by a fraction to remember the rule that you multiply by the reciprocal. But there's a more general rule that's more helpful. And that's that this entire fraction here, the whole thing, the 16 over that other fraction, that entire fraction is called the complex fraction because it has within the denominator a denominator. We don't like that. We just want one numerator, one denominator. We don't want it all mixed up in a mess. So what I can do to get rid of that mini denominator is multiply the top of this and the bottom of this by root 3. And what happens on the bottom of my entire fraction is these cancel, and I'm left with 16 root 3. And what that means is that L, let me write that down so we can see it, L is equal to 16 times the square root of 3. And I go back up here to my diagram. This is 16 root 3, which means that entire base is 16 plus 16 root 3. And now I have to simplify this. Well, I don't have to. That's the answer. But what I would tend to do visually when I look at this is notice that I have this 1/2, and I'm multiplying by 16, so that's 8. So I can combine those two and say that's 8 multiplied by whatever 16 plus 16 root 3 is. Well, the way I just said that, let me point something out to you. I said multiplied by whatever 16 plus 16 root 3 is. You know what 16 plus 16 root 3 is? It's 16 plus 16 root 3. I didn't mean to imply that we're going to go to the calculator and start calculating, because then we end up with a decimal approximation of an irrational number. And I don't know what I have for an answer. One of the things I could do is I could multiply that 8 through, is that 124? 128? Okay, so I could multiply the 128, the 8 through, and get 128 plus 128 root 3. Or I could factor the whole 128 out and just write 128 times 1 plus root 3. But that's the exact value of the area. Is that okay? All right. Any other questions? Yeah. Number 2? Yeah. So this is the one with the boom on the crane. What you're asked to determine here is, as the angle changes from 60 to 30 degrees, what's the vertical displacement of the top of the boom? When you look at this diagram, Aoki, in this triangle, you have enough information that you can calculate the height of that triangle. I know the hypotenuse of that triangle is 10, and the height is opposite the 60, and what that means is that I can use, let's see, opposite and hypotenuse is tangent. I can use, no it isn't, sine. I can use sine of the 60 degrees equals the height. I'm going to call this entire distance which I'm finding m. It's just the letter, it doesn't stand for anything. The height, which is m over 10, which means that m is equal to 10 sine 60. We'll come back to that in a bit, okay? But that's what m is equal to. On the other hand, I can take a look now at this triangle. And I have enough information in that triangle to find out its height, and I'm simply going to call this n. It's opposite the 30 degrees, and the hypotenuse is still 10, because it's a crane boom. Like, the length of it doesn't change as the angle changes. It just rotates about a pivot point. So for that, I can write sine of 30 degrees equals the opposite side, which is n, over 10. And that means that n is 10 sine 30 when I cross multiply. Good? So I think it's pretty obvious here that that vertical displacement is the difference between those two things. I could simplify each of them first, but what I'm going to do instead is I'm just going to write that the vertical displacement d is the bigger number, which is 10 sine 60, minus the smaller, which is 10 sine 30. And then what I'm going to do is put in what the sine of 60 degrees is. I'm not going to go to my calculator, though. The sine of 60 degrees is root 3 over 2. When I look at that triangle, minus the sine of 30 degrees is 1 over 2. How many of you have recognized that for sine and cosine, if it's a 30 degree or a 60 degree angle, one of them is a half and one of them is root 3 over 2? Okay. Well, you can always just check if you wanted to. Just take your calculator and go take sine of 60. What's sine of 60 on your calculator? 0.866 something. Okay. Well, that's sure not 1/2, is it? So that must be root 3 over 2. And actually, after a while, you will recognize that root 3 over 2 is 0.866. You'll recognize that number. Now I can simplify this. What I end up with is The 10 divided by the 2 gives me 5, multiplied by root 3 minus the 10 times 1 over 2 gives me 5. So this is the length of the vertical displacement. All right, we're going to move on now to looking at how we calculate trigonometric ratios on the coordinate grid. We're also going to go back to those triangles today and do a little bit more work with them. And we will do so in a bit. But we're going to be doing a lot today. And in the objectives, I'm indicating to you what the examples are that go with the objectives. And when you get to the homework assignment, it will be telling you which examples go with which questions. There's a lot going on here that you need to keep track of. So we're going to be finding trigonometric ratios for rotation angles, not for angles in triangles, for rotation angles if we know a point on the terminal arm of a rotation angle. And if we know the angle and it's a special angle, one of those angles we talked about yesterday, we need to know how to find the exact values of the trigonometric ratios, not just for 30, 60, and 45, but for any of them on the grid that are special angles, like 225 degrees is a special angle. 330 degrees is a special angle. And then also, if I give you one trigonometric ratio, you have to be able to find the other two. So we're going to have to learn some new ideas here. If we have a terminal arm that's in quadrant 1, and that diagram that you're looking at shouldn't be anything new to you, I don't think. It should be pretty obvious. The only thing that maybe is different is I've labeled a point on the terminal arm now. That point is labeled as point P, and it has coordinates of x, comma, y. Number 1a says, oh, and by the way, there's a note here. Notice that the rotation angle, which is what I have in red, also happens to be the reference angle, which I haven't even labeled on there. Okay. The first question says, if you knew x and y, how could you find r? R is defined as the distance from the origin to that point. So r is this length. And the question is, if you knew the number for x and the number for y, how could you determine the length of r? Gustav? Sure, the Pythagorean theorem. Because if we create, and this language is important, if we create a reference triangle, a triangle that uses that point and the x-axis, we'd never, ever want to create a triangle by drawing a line over to the y-axis. This is called a reference triangle because it contains the reference angle. Okay? You don't need to draw in the reference angle there, but I'm just saying that's how we have to draw the triangle. You can see that this is x and this is y, and since we're dropping a line right down vertically to the x-axis, it's the Pythagorean theorem. It's a right-angled triangle. X squared plus y squared equals r squared. That's it. Write an expression for each of the following. What is the sine of theta? This is the most important thing so far. We're not going to use the words opposite or adjacent or hypotenuse anymore. Looking at that triangle, since sine is opposite over hypotenuse, we have to say this now. The sine of the angle is y over r. And this is why it's important that you draw your reference triangle the way I did it. It has to be so that you drop a line to the x-axis. And if you do that properly, y will always be opposite the reference angle. And in this case, that's opposite the angle. Cosine is adjacent over hypotenuse, so we say x over r. And tangent is opposite over adjacent, so that's y over x. And don't just copy that down blindly, but think carefully about why I've written what I've written in terms of the traditional definitions of sine, cosine, and tangent. Sine is opposite over hypotenuse. But in that triangle, y is opposite and r is the hypotenuse. You catch my drift here? Okay. So we have to change our way of thinking. What is true about the nature of x and y in that quadrant? What I mean is the positiveness and negativeness. You know, of course, on the coordinate grid that x can be negative or positive in different places, and y can be negative or positive. But what is always true in quadrant 1? They're all positive. So what we know is that in quadrant 1, x is greater than 0 and y is greater than 0. By the way, r is greater than 0 everywhere. I know this is talking about quadrant 1, but if we were to go to quadrant 2 or 3 or 4, x and y are no longer both positive, but I'm telling you r is always positive. R is a distance. So what can you say about the 3 trigonometric ratios? Well, sine of theta, and you can just look up 2 centimeters in your notes. Sine of theta is y over r. But y is positive and r is positive, which means sine of theta will always be positive in quadrant 1. And it's at this point in time that maybe some of you are going, yeah, so what? I mean, it's all positive, big deal. Well, it's not going to be if it's in a different quadrant. Cosine of theta, if you just look up a couple centimeters in your note package, well, you just wrote down cos of theta is x over r, but in quadrant 1, x is positive and r is positive. Well, r is always positive, which means cosine is positive. Tangent of an angle is defined as y over x, and if y and x are both positive, then tangent must be positive. And I don't know if I said this, but maybe I should. You know, if sine of theta is a y value over r, and this is positive and this is positive, when you divide a positive by a positive, you get a positive. That's what's going on here. So what does this mean? It means if you were to take your calculator, and this is going to be no surprise, but if you were to take your calculator, make sure it's in degrees, and pick any angle in quadrant 1. It's got to be more than 0 degrees and less than 90. 1 degree, and take the sine of 1 degree. You're going to get a positive number. 35, take the tangent of 35. You're going to get a positive number. In this quadrant, all of the trig ratios are positive. 370 degrees is in quadrant 1, because if I compare it to a full revolution, it's 10 degrees more. So if you watch my arm, 370 degrees is this rotation, plus 10 more. It's in quadrant 1. If I take the cosine of 370 degrees, I get a positive because it's in quadrant 1. So in quadrant 1, they are all positive. And I'm writing a big A for a reason, but in quadrant 1, they are all positive. What about quadrant 2? Well, sketch a rotation angle, any rotation angle that lands in quadrant 2. Here's one. Put a point on there and use a reference triangle, which means we have to drop a line down to the x-axis. Now this is the rotation angle. This is the reference triangle, or reference angle rather. Write an expression for the following and identify which are positive and which is negative. Now, we're going to have to grapple with the fact that your textbook does something which I'm going to say is wrong here. Okay? Let me write out what's correct. and then I'll tell you what your textbook says in case you look there. When you look at this triangle, and you look at the fact that this is the point, this is y, and this is x, yes? Okay. So in terms of that triangle, opposite is y. And the hypotenuse, of course, is r, which I didn't put in here, but this entire distance, which I'm just going to highlight for you, this distance is r. It doesn't matter, let's get this out of the way, it doesn't matter which quadrant it's in, sine of the rotation angle will always be y over r. Okay? Even if it's in quadrant 3, because if it's in quadrant 3, you're going to draw a line from the point up to the x-axis, and the opposite side will always be y. Cosine, looking at this, is x over r, and tangent is opposite over adjacent, which is y over x. And I understand, and that's correct, I understand what your textbook does and why it does it, but I think it can cause problems for higher level thinkers. I'm going to add something to this that I don't want you to add because it's wrong. What your textbook does is this. It says that's cosine. And it's trying to communicate to the student that in that quadrant x is negative. But that's wrong. Because if this number is negative 3, and I put it in here for x, your textbook is saying it's negative negative 3, which is 3. It's not. It is x over r. And if x is negative, then that ratio becomes negative. Okay? So I'm telling you that these three definitions that I have for sine, cosine, and tangent here are identical to the ones I had here, and they're identical anywhere on the coordinate grid. But looking at this diagram, you should understand that in quadrant 2, sine of theta will be positive because looking at the diagram, y is positive in quadrant 2. Well, heck, I don't think you even need a diagram. You should be able to see in your head that in quadrant 2, y is positive. And you should be able to see in your head that in quadrant 2, x is negative. And that would mean that cosine of an angle in quadrant 2 will give you a negative value. What about tangent? Positive or negative? What do you think? It will be negative because y is positive and we're going to divide by an x coordinate that's negative, and that means that tangent of the angle will be negative. By the way, you have to put the angle there. Don't just write tan. And that means that in quadrant 2, only sine is positive. Let's just try this. Everybody pick your own personal angle that you know is in quadrant 2 and take the sine of it. I'm going to pick 112.8, which is past 90 but less than 180. It's in quadrant 2. The sine of 112.8 is positive because in quadrant 2 sine is always positive. The cosine of 112.8 is negative because in that quadrant cosine is negative. The tangent is negative. You know, the number itself we'll talk more about as time goes on, but for the time being, this is the important point. And then what I say is, this can be continued, so these are some notes at the bottom of the first page of this lesson. This can be continued for quadrant 3 and 4, and I'm going to show them to you, but we're not going to write them down. Okay? The x-coordinate is always something you connect with adjacent. The y-coordinate is always something you connect with opposite. and r is always the hypotenuse. Now, I do say in here, both x and y can be positive or negative depending on the quadrant. And I say that on page 90, there's some information that you can look at. But be aware, they put negatives in when they shouldn't. They'll say negative x and just say instead of saying x. Let me show you my way to clean this up. And I'm going to put all 4 of these on a single sheet and photocopy it for you. Okay? In quadrant 1, what are we talking about here? We're talking about x being positive and y being positive. So in quadrant 1, in terms of sine, cosine, and tangent, they will all be positive, won't they? Don't let that just roll off your brain. Think about it. Sine is y over r, cos is x over r, tan is y over x. They're all positive because x, y, and r are all positive there. However, in quadrant 2, y is positive, but x is negative, and that means the only thing that's positive in this quadrant is sine. Correct? We didn't do this one, but I'm going to put it up here and ask you to think about it. X is negative in quadrant 3, y is negative in quadrant 3, r is always positive. Oh, and what do you think sine will be, which is y over r?
Negative.
Excellent. Because y is negative and r is positive. Aoki, what will cosine be? Excellent. Because x is negative and we're dividing by a positive r. Greg, what will tangent be?
Positive.
Positive, good. Because x and y are both negative, when you divide y by x, you divide negative by negative, which is positive. That means in quadrant 3, the only thing that's positive is tangent. What about quadrant 4? Okay. In quadrant 4, let me write this down first. X is positive. It's to the right of the origin, and y is negative. EL, you go by, right? EJ, I'm sorry. I apologize. EJ. What will sine be? Negative is right, because y is negative and r is positive. Declan, what will cosine be? Excellent, because cos is positive, because it's x over r, and x is positive here. R is always positive. Taylor, what will tangent be? Negative, because it's y over x, y is negative, x is positive. So in this quadrant, the only thing that's positive is cosine, right? So that requires some thought, and I guarantee you when you get to math 30, you will think it through and you will not do what I'm about to show you. But we said in quadrant 1, they are all positive. And in quadrant 2, only sine was positive. And in quadrant 3, only tangent is positive. And in quadrant 4, only cosine is positive. Years ago, when I was in high school, and some teachers still use this, we called this the cast rule, because it spells the word cast. I don't like that because the word is cast, but the first letter of the word is not in quadrant 1, it's in quadrant 4. So we've come up with different things. Some people say add sugar to coffee. But there are different ways you can memorize this. Rather than having to reason it out, although I think reasoning out is the better thing to do, if you're confused by it, you can do that. And what this is telling you is what's positive in the quadrants. They're all positive in quadrant 1, only sine is positive in quadrant 2, then tangent is only positive in 3, and only cosine in 4. Okay. All right. So what happens now, if you turn the page, what happens is this. Grade 10 is what you're looking at on the board here. And that would be on a formula sheet in grade 10. This is grade 11, and this is what we're looking at, and this is what's on your formula sheet. So let's put this into practice. The point 5, 12 is on the terminal arm of a rotation angle, and this is not difficult stuff. Okay? There's a couple of little twists to it, but it's not tough. What is the value of sine of theta? I'm not asking you for theta. I don't want to know an angle. I'm saying what is sine of theta? Well, sine of the rotation angle is defined as y over r, right? If I say what is cosine, it's x over r, and tangent is y over x. And by the way, the math teachers, we've debated whether we should even give you these on a formula sheet. I argue that you shouldn't need to be given them because you're not given them in Math 30 where you need them. And I argue that you shouldn't need to be given them because I think if you do enough of these questions, you will remember them. But they're there if you need to. Look at them. So what are we missing here? Well, we can do tangent. Right? This is x. This is y. Well, tangent is 12 over 5. Tangent of the rotation angle has a value of 12 over 5. But what are we missing that's preventing us from finding cosine of the angle or sine of the angle? Do you know, Gustav? Well, that's true. We don't know the angle, but we don't want to walk down that road. We don't want to find the angle to determine the sine or the cosine. Paige? We don't have r. Right? We know x, we know y, we don't know r. But we do know that x squared plus y squared is equal to r squared. So this little part of the problem is a junior high question. And I like putting brackets around stuff even though you don't need them here. I would like everybody to work out what 5 squared plus 12 squared is. And 169. Is 169 a perfect square? In other words, if we take the square root of it, do we get a nice number? 13? Yeah. We don't get decimals. If we got decimals, then we'd leave it as root 169. We want exact values. So r is equal to 13. Oh, this is simple. Y is 12, r is 13. X is 5, r is 13. We're done. Those are the trigonometric ratios. Any questions with that example? What about if we had negative 8, 15? Well, again, we can put tangent. I better write this down. Tangent of a rotation angle is y over x. Sine is y over r. Cos is x over r. You know, there's going to come a time, and it's probably going to happen in this lesson, where I'm not going to continue to write those down. We know what they are. And in fact, that's what I initially did here. I was going to write this. And then I said, oh, wait, I'd better write down y over x. That's the tangent of the angle. However, (15 over negative 8) and negative 15 over 8 and negative 15 over 8 are all the same. I despise this. I don't like putting a negative in the bottom. I'm okay with this, but the problem is when you type it out that way, that negative is very close to the line on the fraction, and sometimes you don't see it. Your brain just sees a line there. I much prefer this one. So the tangent is negative 15 over 8. Be careful here. Tangent is y over x. I'm not saying y is negative. I'm not saying y is negative 15. I'm saying y over x is negative 15/8. We're missing r, by the way, here. So we have to go x squared. You need this set of brackets. If you don't have the set of brackets, it's not that you're going to get the wrong answer. What you've written is wrong. Negative 8 squared without brackets means square 8 and put a negative in front. It's not what we're doing. We're squaring negative 8. Plus 15 squared, we don't need the brackets here, equals r squared. So we want to figure out what that's equal to before we take a square root. I want to say 289 is the number that just popped in my head, and I think that's a perfect square. Of 17. So we get r squared equals 289. I'll change that cube to a squared. I don't know where that popped out of my brain from. Which means r equals the square root. You know, it occurs to me in the previous question, I really ought to have written, just to make sure that I don't lose anybody, that r equals root 169, right? That's what we did to get to 13. In this question, we're taking the square root of 289, and Paige, you said it was 17. Okay. So that means sine is y, which is 15, over r, which is 17. Cos is negative 8, which is x over 15 over 17, which is r, and we're done. Capiche? All right. So now we're going to do a question that seems out of left field, okay, but it's not. What is the exact value of the sine of 240 degrees? So the first thing you need to do is you need to locate where 240 degrees is. And by my count, it's 60 degrees past 180. So it's going to look like this. And I like what I see there. I just saw two people looking back in their handout for something. That's good. Because when we create a reference triangle, and I'm going to do the following. I'm just going to put a point here, and I'm going to create my reference triangle. This is a 60-degree angle, and this is a 30-degree angle. And I could have maybe drawn that a little better. How's that? There we go. This is one of those triangles. Now, I don't want to get too deep into a point here, but this point that I put could be anywhere on there. I could draw this point so that r is 1,000,000, or I could draw that point so that r is 5. I'm going to draw that point so that r is 2. Because I know if r is 2, x is 1, and y is the square root of 3. I didn't write them in yet. I don't want to. But do you get my drift that I'm going back to that triangle from yesterday? Except, listen carefully, is x 1? What is x? It's negative 1, because it's in that quadrant. And is y the square root of 3? No, it's the negative of the square root of 3, because it's in quadrant 3. What we're talking about here is looking at this triangle I'm going to get rid of this in a second. I'm not going to keep this mess up here. We're looking at this triangle, and we're using the definition of sine, because it's sine of 240. Sine is y over r. So y is negative root 3. R is 2. That's what we're doing. This is equal to negative root 3 over 2. It's equal to y over r. Do me a favor, please. Take your calculator. Put your calculator in degree mode. Well, it should be already. Take the sine of 240 degrees. Now take your calculator and figure out what negative square root 3 close brackets divided by 2 is. It's the same number. How many of you, when you did sine of 240 and you saw negative 0.866, knew it was negative root 3 over 2? Because you've seen that number before, right? Okay, so what about cos of 315? Well, 315 degrees, and this goes back to 2 days ago, I believe is the 45-degree position in quadrant 4. It's 45 degrees shy of 360. So this is what it looks like. I just cannot draw 45-degree angles. My brain, something weird happens in my head when I try to do it. This is one where we're going to pick a point. We, of course, construct the reference triangle. This is y, this is x, this distance is r, but we're going to choose r as 2. Why are we using 2? Because we have learned that if that's 2, these two sides are root 2. And in the course of writing this down, I'm intentionally making a mistake. Can somebody point out what the mistake is? Which one? The y should be negative. It's negative root 2. Now, it turns out that doesn't matter because cosine is x over r. So who cares what y is? But it was a mistake. Cosine is x over r, so cosine of this rotation angle will be root 2 over 2. Good? Okay. Let's try just a couple more. Number 3, and correct me if I'm wrong, there's a 3a and b. Okay. 3 says that cosine of a rotation angle is 9 over 41. What's sine and what's tangent? Well, sine is y over r, tangent is y over x. If you're told cosine, and you know that cosine is x over r, then you are allowed to say that x is 9 and r is 41. You are allowed to do that. Now, it may not be true. It may be that x is 18 and r is 82. But the ratio of the two is always the same. So you can pick a point on the line somewhere where x is 9 and r is 41. Notice we're missing y for both of these. Well, we find y. X squared plus y squared equals r squared, so we can go 9 squared plus y squared. I guess I don't need brackets anywhere there. Plus y squared equals 41 squared. Everybody, you're familiar with this idea that since it's not the hypotenuse we're finding, you're going to have to subtract. So you're going to take 441 square, you're going to take 41 squared and subtract 81. And let me know what you get. 1,600? So you get 1,600. Now, I have to teach you something. All of high school math is so seamless. It just goes along in a perfectly logical line, and there's this one thing that we need to know here that you haven't been taught yet and won't be taught for a while. Can you figure out, and I'm going to teach it to you, what is y then? Everybody says 40, right? Because you take the square root. But You can write this. When you say y is 40, you're saying that because the square root of 1600 is 40. I get that. But what you're telling me is 40 is correct because when you square 40, you get 1600. Think of it that way. Is it true that when I square 40, I get 1600? Is there another number that I can square that will still give me 1600? Negative 40. And now, from here on forward, from this day on, when you take the square root, you have to write this. Plus or minus the square root. This means plus or minus 40. What does that mean? It means y equals 40. Y is equal to 40. And y is equal to negative 40. There's two answers. There's two solutions to this equation. And we have a lesson on, well, we have a whole unit on the nature of this whole two different solutions thing. 2 units, actually. But if I'm telling you there's two answers for y, and we have to write y over r and y over x, which is it? Do we flip a coin? Do we use both? How many of you know which one we use? What is it, Ashira? Why is it negative? Right. There's that detail in the question that says the angle terminates in quadrant 4. Well, in quadrant 4, y is negative. So when we got to this conclusion that y equals positive 40 and y equals negative 40, we throw that over the boards. We don't want the positive. And that means the answer is, for sine, negative 40 over 41. That's y over r. And for tangent, it's negative 40 over 9. And you know, that's kind of that cast rule, but I think it's better if you just say, well, what's quadrant 4 look like? Oh, that's where y is negative. I think that makes more sense. Rather than going, oh, cast, oh, that's C, only cosine is positive, so I have to make sure tangent and sine are negative. It doesn't really make sense to me. Try one more. An angle has its terminal arm in quadrant 3. Tangent of theta is 8 over 3. Tangent, of course, is y over x. So if we want sine of theta, that's y over r. If we want cos of theta, that's x over r. We're missing r, aren't we? Would you agree? So I'm going to use x squared plus y squared equals r squared. So I'm going to have 3 squared plus 8 squared equals r squared. I don't think we're going to get a perfect square this time. So we're going to have to talk about what to do with that. We don't want to write decimals. Decimals is for, you know, maybe 10C or 20-2 where we're looking at more applications. Here we're looking at a pure kind of math. 73. So if r is equal to 70, r squared is equal to 73, that means r is equal to the square root of 73. Hang on. Why didn't I write plus or minus? I mean, I should. Maybe I should. Maybe I should. I just taught you whenever you take the square root, put plus or minus. That means r is root 73 and negative root 73. But why am I just throwing that out? R is always positive. Okay, so now we can write y over r. So that's 8 over root 73. and x over r, which is 3 over root 73. There's something I want to discuss with you about this question, but before I do, about those numbers, before I do, any questions with that? Are you okay with that? Because if you are, I suckered all of you into getting wrong answers here. Why should y be negative? But, yes, but, and I'm just kind of playing the fool here, but how come I don't see a negative up here? How come it doesn't say negative 8 if y is negative? Oh. Because x is negative as well. In quadrant 3, x and y are both negative. So when you take y divided by x to get tangent, the negatives get hidden from view. They're not there. This is the one that will always try to fool you on an exam. It's actually this. But, you know, because you square x and square y, when you square those negatives, it's not going to change the number 73. You're still going to get 73. It's just that these numbers, y and x, are both negative. And one final thing, and then I'll let you get some practice here. Do you remember how I told you, and we've actually done this on the calculator, that 1 over root 2 is the same as root 2 over 2? And 1 over root 3 is the same as root 3 over 3. 1 over root p is the same as root p over p. Well, that means that I could write this as negative 8 root 73 over 73. The 1 over the root 73 can be written instead as root 73 over 73. It's really clunky. I think writing it the first way is better. It's simpler to look at. But later on, we're going to learn that this is the proper way to write it, and you will know how to go from one to the other. And this could be written as well as negative 3 root 73 over 73. Again, this is the proper way to write it, technically correct, but I don't like it. It's a little too, there's a little too much going on there. I think it's easier to just say negative 3 over root 73. But one of the reasons I mentioned that is we'll see it later, but the other reason is you might do some textbook questions, and when you look in the back, they might have given that as the answer as opposed to the first version that we got.